Activation of the immune response typically begins when a pathogen enters the body. Macrophages that encounter the pathogen ingest, process, and display the antigen fragments on their cell surfaces. Macrophages with antigen fragments displayed on their surfaces are called antigen-presenting cells. An antigen-presenting macrophage interacts with a T helper cell that can recognize the same antigen. During the interaction, the macrophage releases a chemical alarm signal called interleukin-1, which stimulates the T helper cell to secrete interleukin-2. Interleukin-2 causes the proliferation. When B cells become activated by T helper cells, they differentiate into plasma cells. These plasma cells become antibody-producing factories, flooding the bloodstream with antibodies that can bind to the antigen involved in this infection. Antibodies bind to the antigens on the surfaces of the pathogens, marking them for destruction by macrophages. Some of the B cells do not turn into antibody factories, but instead become memory B cells that may survive for several decades. Because of these memory B cells, the secondary immune response to a future infection by the same pathogen is swifter and stronger. This powerful secondary immune response is what gives immunity to some diseases after you have had them once or after you have been vaccinated.